All right, chemistry kids, in today's video, we're going to be going over measurement, or how to take a proper measurement using different types of instruments. Basically, it's going to be focused on like what happens when you're trying to take a measurement that has tick marks, like a ruler has the calibrations on it. A graduated cylinder has the calibration marks on it. Okay, they're called graduations. You can call them graduations, calibration marks, tick marks, however you want to call it. But things when you're reading and it has lines on it, and depending on how far along the ruler it goes or how high in the graduated cylinder it goes, you read the tick mark, and the tick mark tells you the measurement, or really what you're doing is you're reading the graduation and it tells you the number to write down. Okay, so we're talking about those. We'll do a little bit, we'll talk about the digital stuff because we do digital measurements. But for general and honors chemistry, this is either 1-1 or 1-2 on your visible learning objectives. But measurement in SIG-DIGs, 1-1 and 1-2, those two visible learning objectives, whether you call one 1-1 and the other 1-2 or vice versa, it really doesn't matter. They all tie together. Okay, so this is the part of either 1-1 or 1-2, depending on what level of chemistry you're in, how to take a proper measurement. Okay, and again, it ties in with SIG-DIGs. Everything kind of goes together. Okay, so digital balances, well, first of all, just understand, like, to have a measurement, you need a value, okay, and you need a label or unit, okay? So a number, right, sometimes called a magnitude, okay, or a value, okay? So 5, that's a value, okay? But 5 what? You know, I asked my students the other day, I was like, hey, ask me how much I weigh. And they asked me how much I weigh, and I just said 100, okay? Well, 100 what? I don't weigh 100 pounds, but I do weigh around 100 kilograms, okay? So if I said 100 kilograms, okay, then you know it's not pounds. But if I just say 100 and you're assuming pounds, then you realize I'm lying to you, right? You need that unit, you need that dimension as well. So especially in this class, most of your answers are gonna be some type of unit. Whenever you're doing any type of calculation, you'll be, calculating the mass of something. So your final unit is gram. Calculate the length of something. So your unit would be meter or centimeter or whatever unit the instrument is measuring. But you need some kind of label, okay, or dimension. Okay, so unit, label, dimension, they all kind of mean the same thing. Okay, so taking a measurement on something that's digital, like a digital balance or a digital thermometer, you just write down what's the screen shows you. Okay, so like this balance, it'll show you a number in 4 decimal places. So if I'm measuring something here, it's going to go to 4 decimal places. So let's imagine if I had a screw that I was measuring the mass of, and it weighed exactly 2 grams. Okay, if I weighed that screw here, it would read 2.0000. And so that's what I would write down. And then I would write down grams, or G, because that's the unit for mass that we use, okay? Then once we have that many grams, we could convert it to kilograms, we could do all the conversion stuff. We'll talk about that in another unit. But if I took that same screw, but I put it on this balance, it would read 2.00, and that's all I could write down. So if I was using this balance, all my measurements will go to 2 decimal places only. But if I'm using this balance, then I can go to 4 decimal places. Okay? If I'm using this thermometer, I can go to 1 decimal place. If I'm using this thermometer, I can go to 1 decimal place. Okay? If I was using this thermometer, my unit would be Celsius. If I'm using this thermometer, my unit would be Fahrenheit. We'll never measure in Fahrenheit, okay, unless I specifically go out of my way, but we'll use Celsius. Our thermometers can measure either one, but whenever we measure temperature, it's going to be on the Celsius scale, just a heads up moving forward. But again, you got to have the unit too. Okay, so if I'm using this, and that was my measurement, I wouldn't just write 12.8, I'd write 12.8 and then degrees Celsius. Here, I'd write 97.3 and then degrees Fahrenheit. There's nothing else I have to do, I just have to write down what the instrument says. Okay, now if this instrument had a 0 here, because it could read to 2 decimal places, then all my measurements would go to 2 decimal places. But for this thermometer, it can only go to the tenths place. This thermometer can only go to the tenths place, so if I'm taking measurements with these, I'm only going to the tenths place. Okay, just writing down what I have. Okay, and whenever you're taking a measurement, especially when we get into the calibration part of it, or the graduations, how to read the graduations, and how to write down all the digits you're allowed, you really need to know your places. So when I say tenths place, right, I'm talking about this. If I say hundredths place, I'm talking about this. But if I say ones place, this is the ones. If I say tens, not tenths. If I say tens, the tens place, the hundreds place, right? So you got to know what place, okay? And then we'll talk about what to do, okay? But let's talk about, things that have graduations. So what are those things that we'll use in this class? Graduated cylinders, some rulers, burettes. We don't really ever use the old style balances. We'll use digital balances, so we don't have to really worry about that. But it doesn't matter what the instrument is. If it has lines on it, graduations on it that you have to read, this is how to take a proper measurement with that type of instrument, okay? The first is know what unit you're measuring, right? So like if I'm using a graduated cylinder, right? Milliliter, right? If I have a balance here, maybe pounds. But, in our class, we're going to be measuring grams, but we will learn how to convert grams to pounds or pounds to grams, or really pounds to kilograms and then kilograms to grams, that kind of thing. Okay, but it has lines on it. It has tick marks. It has graduations. This is what a burette is. It's kind of like a graduated cylinder, but it's kind of upside down and it goes backwards. So 0 at the top and 50 at the bottom. But this is a burette. But what we're talking about graduations are these little lines here, right? The ruler is graduated. This cylinder is graduated, hence the name graduated too. Now here's a cylinder that's graduated, but we don't call this a graduated cylinder. We call it a burette, okay? But graduations just mean those lines on the instrument, okay? So here are the graduations, right? So know what unit you're measuring, but then whatever instrument you're going to use that has those graduations that you're taking the measurement with, figure out what each value, as you go from one graduation to the next graduation, what value does that hold, okay? So like what I mean by that is if we zoom in on this burette, here, I'll zoom in, right? Here's 0, here's 10, and we have lines in between. So 0, this would be 0.1, this would be 0.2. So as we go from one graduation to the next, it's 0.1. 0.1 what? 0.1 milliliters. So each graduation in this burette is worth 0.1. Okay, 0.1 milliliters. If it was the same graduation here, like I can't really read this that well here, but if these graduations on the ruler look the exact same as these graduations over here on the burette, here, let me get a hand there, over here on the burette, then it would be increasing, each graduation would be an increase in 0.1 centimeters. Here it's 0.1 milliliters because that's the unit we're measuring over here. Here would be 0.1 centimeters if it was the same graduations, okay? So here's the deal. If you know what the graduation is worth, 0.1 milliliters, 0.1 centimeters, that gives you the tenths place. That's what the graduations give you. Whenever you're taking a measurement with any type of instrument that has graduations, you need to take one estimated digit, so basically to the right. So if the calibrations are in the ones place, then I need to estimate to the tenths place. So all my measurements would have 1 decimal place, okay? But if I had graduations that gave me the tenths place, 0.1, then I need to estimate to the hundredths place. So if all the graduations are 0.1 milliliters, like in that burette I showed you, then all the measurements I take with that particular burette should have 2 decimal places, okay? So if I was using this burette, the calibration gives me 0.1, which is the tenths place, so my estimated digit is the hundredths place. And so all my measurements using this should go to the hundredths place. Now you got to remember that, especially when what you're measuring falls exactly on the line. If it falls exactly on the line, a lot of times, like let's say you were measuring something and it was right on the line here. That would be 0.5 milliliters, right? But if you just wrote 0.5 milliliters, that would be an improper measurement because all of your measurements should go to 2 decimal places for this particular instrument. So if you think it's 0.5 right on the money, then you need to say 0.50 milliliters. Okay? Now, when it falls between the line, a lot of times students will remember to estimate a digit. But when it falls right on the line, people forget that they need to take that estimated digit. Okay. So again, know what unit, right? For volume, like graduated cylinders, burettes, it's milliliters is what we usually measure. For rulers, it would be centimeters. I mean, you could measure inches, but we're going to spend most of our time with the metric system, so centimeters most likely, okay? And then centimeters easily convert to meters, right, if we needed to convert, okay? For balance, we could do pounds, but once we measure the pounds, we convert it to grams, but the balances we use, we're going to use the grams setting. And then thermometer, we're going to use degrees Celsius. Now, once we get to degrees Celsius, we're going to convert it to another temperature scale called the Kelvin scale. So we'll convert from Celsius to Kelvin, Kelvin back to Celsius, but we really won't ever use Fahrenheit, okay? And then know the value of the calibration, and then know that you need one more place to the right on the number line beyond that place. So if it's 0.1 centimeters, if each calibration is worth 0.1 centimeters, then I need the hundredths place. I need to if that's what the calibration represents on my ruler, then all my measurements need to have 2 decimal places. I need to estimate that hundredths place. But that's it. I can't go further than that. I can't go to the thousandths place. But if everything on my ruler was an increase in 0.01 centimeters, then I would need to estimate to the thousandths place, and then all the measurements using whatever this ruler was would have to go to the thousandths place, okay? So let's look at this ruler. If we look at it, here's 1 centimeter, here's 2 centimeters, but if we look at the difference between each calibration, it's 0.1 centimeters. So that means if I was using this side of the ruler for centimeters, every measurement I took with this particular ruler should have 2 decimal places. So if I had something that fell right on the money, like here, if I was measuring something and it fell right on that mark here for 1, I wouldn't just write 1 centimeter. That would be an improper measurement. If you wrote 1.0, that would still be an improper measurement, okay? Because this ruler gives you the 0.1, it gives you the tenths place, so you have to estimate to the hundredths place. So if it fell right on the money here, you would have to say 1.00 centimeters, okay? Right? So let's look at this. We have, let's call this centimeters, even though maybe it's not, I don't know. But let's call this centimeters. And notice the graduations are different on each side. So this side has a different precision than this side, okay? So if I was measuring stuff with this side, each calibration, look at, this is 30, this is 40, so this would be 31. Hold on. So here's 30, here's 40, so this would be 31, 32. So as we move from this mark to this mark, that's worth 1 centimeter. So the calibrations or the graduations give me the ones place. So if I was using this side, my measurements could only go to the tenths place. I could only have 1 decimal place. But if I use this side, notice this side, we added an extra graduation there. So this would be 30, this one would be 31, but that would be 30.5. So each tick mark represents 0.5 centimeters. That's the tenths place. So if I was using this side, I would have to estimate to the hundredths place. So this side, I would have 2 decimal places for each of my measurements. But if I was using this side, I could only have 1 decimal place for each of my measurements. Okay. All right, so hopefully that makes sense. I have it kind of in words here, but I think what I just explained out loud makes more sense. Okay, and then let's look over here. This would be a graduated cylinder. So we first need to know, okay, we're measuring milliliters here, okay? And then what we have to do is find what each tick mark represents. So this one's a little bit different. So this is 8 and that's 10. So this one right here is 9. So it would be 8, 8.2, 8.4, 8.6, 8.8, and then up here would be 9. So each calibration represents 0.2 milliliters. But again, that is the tenths place. So I need all my measurements to go to the hundredths place. So any measurement taken with this graduated cylinder has to have 2 decimal places. That last decimal place, that second decimal place, could be 0, but you need to write that down. Okay? If the meniscus fell right on 4 here, you'd have to write 4.00 milliliters. You'd have to have that 0.00 for it to be a proper measurement. If you just said 4.0, that's not proper. And again, it's about significant figures. If I see the measurement 4.0 centimeters, or milliliters, if I see the measurement 4.0 milliliters, that's 2 sig digs. But if I see the measurement 4.00 milliliters, that's 3 sig figs. Okay? So understand, this graduated cylinder gives me 2 decimal places, and so that means every measurement should have 3 significant digits at least. If I got up to 10.00, that would be 4 significant digits. Okay? But if I shortchange myself, if the instrument gives me 3 sig digs, but I only report 2, and then I go do math with that measurement later, right? Because how do we get density? Mass divided by volume. So I measure the volume, I measure the mass, I do mass divided by volume. Well, if my mass has 4 sig digs, but my volume only has 2 sig digs, then when I report my density, it can only have 2 sig digs. Okay? But if I was using this graduated cylinder, my volume should have at least 3 sig digs. Okay? But if I only wrote it down with 2 sig digs, then that's what I would be thinking. Okay? You have to report your measurements with the precision that that particular instrument that you're using allows. Okay? So let's look at this one. This graduated cylinder, each graduation is 1 milliliter, right? Here's 40, here's 50, so 40, 41, 42, 43, 44. So going from this tick mark to tick mark, calibration to calibration, graduation to graduation, it's 1 milliliter. So that's the ones place. So I need to estimate to the tenths place, always. So if this landed right on 40, and I wrote 40 milliliters and that's it, that wouldn't work, right? 40.0, yes. 40.1, yes. 39.9, yes. All right, and again, we call that last digit the estimated digit because your estimated digit might be different than mine. I might look at it and think the meniscus is slightly below 40, so I'm going to say 39.9. You might think the meniscus falls right on 40, so you say 40, but you can't just say 40, you got to say 40.0. Okay? All measurements with this particular graduated cylinder need to have 1 decimal place, but they can't have 2. It's not precise enough to have 2. It's precise enough to have 1, and that's it. Okay? But if you don't have that 1 decimal place, then it's wrong, right? These would not be valid measurements with this instrument. Like 42 wouldn't work. If you thought it was right on the money, 42 right on the money, then 42.0, because you need that estimated digit. Okay? Right. So here, we got 20, okay? We got 30, so each one, again, is 1 milliliter. So if you saw that and thought, hey, it might be a little bit lower than that line, then 23.9. But if you thought it was right on the money, 24.0. But 24, bad, no good, because you're allowed that 0.0, and that 0.0 is significant. Remember, trailing zeros, and you see the decimal point, that is a significant figure. So adding that 0 here turns that 24, this 24 measurement, this measurement has 2 sig digs, this measurement has 3. It's the same measurement, but this is the allowed measurement, and if you only write this down, then you're limiting yourself to 2 sig digs when you should have had 3. Okay? All right, so again, 60, 70, this is 67, but it was right on the money, but if I just wrote 67, that doesn't work, 67.0. But somebody else might write, 67.1. Somebody else might write 66.9, okay? Those would be valid because they have that 1 decimal point. But just 67 wouldn't cut it, okay? And then also the unit, okay? So here, you've seen this picture before, right? This is 6.6, but in this graduated cylinder, we're going up by 0.1 milliliters. So I have the tenths place, I got to go to the hundredths place. So this measurement, 6.6 milliliters, would not work because I'm allowed that 6.60, and so I need to take it, okay? Burettes, okay, the only difference between burettes and graduated cylinders is they kind of, here's 27 and here's 28, so this would be, 27, 27.1, 27.2, 27.3, but again, each tick mark is 0.1 milliliters, so that's why I'm allowed the hundredths place, because the graduations give me the tenths place, and I estimate to the hundredths place, okay? All right. So here's another. Here's 41. This would be 41.5, and it's just a little bit in between 41.5 and 41.6. So my estimated digit is 0.05, so 41.55. But if you just wrote 41.5, no good. If you wrote 41.50, because that was your estimated digit, that would be perfectly valid, but you need that hundreds place for this burette. Okay, so it just depends on the instrument you're given, right? All right, right? If I was using this as my centimeter ruler, then since each tick mark represents 0.1 centimeters, I need all my measurements using this ruler would have 2 decimal places. But here, if I was using this ruler, if we look, each graduation is 1 centimeter. If this were centimeters, so let's just say these were centimeters. So 1 tick mark is just 1 centimeter. 20 or 10, 20, so 11, 12. So if I was using a ruler to measure the same things I was using this ruler with, this ruler I could have 2 decimal places. But if I was measuring something the same thing with this ruler, I could only have 1 decimal place. Okay. All right, so that is, how to take a proper measurement. Really, again, it's only the main concern. You don't really have to sweat digital instruments. It's just those, graduated instruments. And, most importantly in this class eventually, graduated cylinders and burettes, because those are the ones that we'll use in the lab moving forward. In this unit, we'll use rulers every once in a while just for measurement practice. But the ones moving forward, it's going to be, usually graduated cylinders and stuff. Okay? All right.